So in this video, let's talk about the ambiguous case, part 1, for the law of sines. So the law of sines, in order to solve it, if you're given two sides and one angle. But if you're given two sides, such as I given a side angle A and the side B, and then you're given also another side. Let's say A. So there are 4 cases. The first case is A is less than H. So here is the height H, right? Remember that when we trying to apply the law of sines, we are trying to split the right triangle into two, split any triangle into two right triangle. So let's say if they given you the side A, if it's less than H. Oops. So that means your side look like this way. If it's less than H, there won't be no solution. That means there is no triangle at all. Because I know that the vertex to the opposite side, the shortest distance is the height. So if you're shorter than that, that means they can close. That means no solution. Okay. The second case is when A is equals to H. So this is look like this way. When A is equals to H, that gives you what? A right triangle. Your H is equals to A is the same length. So that means you will have one solution for A. I mean, what we're talking about ABCD is for A. Now, the third case is if A is less than B but greater than H. Let's see what happened. So this is side B. Oops. And there is a right triangle. You don't know where's the end. And I know that this is your H. So I know that it's longer than H. So that means your side is either this one or on this way, right? But since it's less than B, that means you cannot pass the side B. If you're smaller than that, that means the furthest you can go is very, very close to B, but not B. Because once you pass B, this side is going to be longer than B. Because our setup is A is going to be in between H and the B. So that means this is not going to be a right triangle, but it's either going to be the red one that we show in here or the blue one that we show in here, right? So that gives us two possible solutions for the side A. Or not just side A, two possible solutions for the triangle. And then the fourth case is A is greater than B. So if it's greater than B, that means it has to be on this side. Because you want to be longer than B. If it's on the left side, there's no right triangle, right? It will be above it, past it. So here is angle A. I need to enable that. So that gives us only one possible for the solution. Okay, so now let's have some look at some example and see what does that mean. So let's look at this example. Let's try to solve this triangle. So if given you alpha is equal to 13.5 degrees, A is equal to 6, b is equals to 8. Let's see if we can solve all of the unknown variable. Let's just draw a random triangle. And let's say this is alpha equals to 13.5 degrees. This is A. Oh no, A should be corresponding to alpha. And A is equals to 6. B is equals to 8. Okay, so now we have one combination that we know, which is sine alpha over A equals to sine beta over B. So here would be our beta. So use the law of science, and we got the ratio sine alpha over A equals to sine beta over B, and sine beta is equals to A times sine beta, and then B times sine alpha, and our sine beta is equals to B times sine alpha over A. And let's plug in the number. B is equals to 8 sine 13.5 degrees over A, which is 6. Let's try that on GeoGebra. That's decimals, sorry. GeoGebra is a different website similar to decimals that you can use. So sine beta is equals to 8 times sine 13.5 degrees over 6. Okay, it's equals to 0.7 something. So during the calculation, you don't want to round your number. You want to try to keep it as detailed as possible so that you will have a more accurate answer. Now, so I got sine beta equals to 0.674768 something something. So how do we solve for beta? We use the inverse function, arc sine 0.764768. This is equals to beta. And again, we can just go ahead and use decimal to solve that. Arc sine this is going to equal to 49.88 degrees. So when it comes to this step, you can just round your answer to a whole number. When it comes to angle, you can either round it to nearest 10, unless I specifically say, hey, I want it to be rounded to a whole number. So most of the time, just round it to the whole number. So in this case, I want to keep it as detailed as possible, because later we're going to use that to solve other angles as well. So right now, the final answer, you can round it, but again, during the calculation, keep it detailed. So this is 49.8864 degree. Again, check this again, has to be in degree because everything we're dealing with is degree. Okay, that's our beta. We found it. I am going to label it in here since we just found it. This is, we solve it. It's not given, so I'm going to use different color of pen. Now, next one is we need to solve for C and the angle C and the side C. So we know alpha, angle alpha and beta. So now the next thing that we are trying to find out is gamma. Gamma is equal to 118 degrees minus 13.5 degrees minus 49.8864 degrees, which is, okay, I just solved for gamma is equals to 19.5.1136 with our decimal, and I already labeled it on the triangle. Again, I use a different color. I know that the black one means given, and the blue one means something that I solved, because we need to check our answer later. We use the same method, which is, let's use A. sine alpha over A equals to sine gamma over C. So alpha is 13.5 degree. Is it 13.5 degree? Yep. And A equals to 6. And the sine gamma, which is 19.51136 degree over C. Cross multiply, so our C is equal to sine 19.51136 times 6 over sine 13.5 degree. Then I use decimal to solve for C. So it's equal to 6 times sine 19.51136 degree divided by sine 13.5 degree. Oh, this is equal to 10.41. Again, I would like you to write all of your answer in this whole group. C is equal to 10.41 and alpha equals to 19.5 degree and beta is equal to 49.8864 degree. Now, we put them back into the right triangle and check if it's the biggest angle corresponding to the larger side. So here, alpha gamma is 19.5 angle, 19.5 degree, corresponding to the longest side, 10.41, and then the smallest angle is alpha, 13.5 degree, and the smallest side is A equals to 6. So that means, yes, this is the right triangle. But if we look back to these cases, we have several possibilities. Either have one solution or two solutions, right? We don't know which one. We found one of the solution, or maybe this is the only one, or there will be another one. So one way to check it is we need to see if H is equals to A or less than A, or A is greater than B. So we don't know which case it is, because if it's in case 3, that means we're going to have two solutions. So one way to do it is let's find out the H. Let's look at this right triangle. So this is H. In this left triangle, we know that this is right triangle. We have sine 13.5 degree is equals to the opposite side over the hypotenuse. The trig function works for the right triangle. The law of sine works for any triangle. H is equals to A times 13.5 degree. Now, let's use decimal to solve it. Let me open decimal. So is A times 13.5 degree, which is 4.5. 4.5. Let me write this down. So our H is equals to 4.586. So in this one, A is greater than H. So what would be that be? Oh, sorry. A is greater than H. A is greater than B. So that means this is going to be the case 3. That means we might have two solutions. So how do we find the other solution? Now, let's get back to how do we find our beta. When we find in beta, we use the arc sine, which is the inverse function here. If you remember that, this didn't give us the exact angle, this gives us the reference angle. And the arc science is going to be in the first domain and the fourth domain. So that means in a unit circle is either to be in here 49.8864 or in here. So right now our first solution set is we just solve that for the first in the first quadrant, that case. So let's say if our beta, we solve it again, the second solution set tells us that beta is equals to 118 degree minus the reference angle. Then what we got is, let me check this out. Which is 113 degree. Approximately 113 degree. So let's say if this is 113 degree and our gamma will be, gamma is unknown. We found beta is 113 degree, the second possibility. So gamma is equals to 118 minus alpha minus beta. So it would be 118 degree minus 13.5 degree minus 113 degree, which is equals to 25 degree. Am I doing it right? Let me use the calculator just in case. Oh, it's 15 degrees, sorry. I'm glad that I checked. So our gamma is equal to 15 degree. Let's see the second set. Let me draw a new right triangle in here. So we have alpha equals to 13.5 degree. Beta, the new one that we found, is 113 degree. And this is 15 degree. Keep that in mind, the triangle that I'm writing doesn't have to be the ratio proportion correct. It just, I write a triangle to help me to solve the problem. It doesn't have to be exact. And then this is our gamma. And the given is B equals to 8 and A equals to 6. Let's try to find the side C and see what happened with our second possible solution. So sine alpha over A equals to sine gamma over C. Sine alpha is 13.5 degree, A is 6, sine gamma is 15 degree over C. So C is equals to 6 times sine 15 degree over sine 13.5 degree. Let me solve that with our (15) divided by sine 13.5, which is 2.77. Okay, so here's our new set. I'm going to write it here. C is equals to 2.707. That's the length. Let's check if this is correct. Well, the shortest side is 2.77, corresponding to the smallest the angle, and the biggest side corresponding to the largest angle. So that means yes, this is another correct solution. So that means we have a two solution set. One is the blue one, the other one would be C equals to 2.707 and the gamma equals to 15 degree and beta equals to 113 degree. So here is our two solution corresponding to two different triangle. Oops, sorry, I covered that up. Let me say this again. So after we found out the angle, you put it down in the right triangle and check gamma is the smallest angle and the shortest side is C. This one checked. And then the largest angle is beta, 113 degree, corresponding to the longest side, B equals to 8. So that means this set also correct. So in this question, we have two solutions. One is this right triangle, the blue one that I circle it. The other set would be the C with the red pen that I circle it. Again, one way to see if they have two solutions is you have to check if A, if it's less than, if it's greater than H, less than B, or greater than B, or equals to H. With different cases, we have different solutions. Okay, I'll see you in the second videos, part 2.